Hello, class. So there were some things that I wanted to discuss concerning the unit circle. Um, One of them was, the referencing of the, quadrant one and some different approaches you can take to referencing that quadrant. Um, but then also, lots of instructors have their students memorize the unit circle, and I'm not really about that life. Like, I would prefer to just kind of teach you to build everything versus versus just kind of try to have you memorize things that won't stay with you. All right, so one of those things we've already kind of talked about, which is building the 30, 60, 90 triangle. All right, and then also building the 45, 45, 90 triangle. All right, so these two triangles uh, pretty much populate the first quadrant of the unit circle. And once you have the first quadrant populated, then everything's really gravy after that, because um, you can reference the first quadrant from any other quadrant on the unit circle. So, and we have 45 here. All right. So using these, we're able to determine the values of each trigonometric function. And so if you didn't know already, we can take, if we want to know the sine of 30 degrees, and we can kind of see that right there, but you'll see something pretty cool here in a second. But if you wanted to know the sine of 30 degrees, using the 30, 60, 90 triangle, and by the way, this is 30 degrees at this point. Using the 30, 60, 90 triangle, we can recognize that since we're starting over here at 30 degrees, and sine in the right triangle properties, sine theta is equal to opposite over hypotenuse. Right? We can see that the opposite from 30 is 1, and the hypotenuse is 2. But once you extend this to understanding of circular functions, we start to look at sine just a little bit different. Circular functions have sine of s equals literally a coordinate. All right. And, this s can be an arc. So, 30 degrees in, radian form, we would need to multiply by pi over 180 degrees. The degrees will cancel, and then 3 goes into itself once, and 3 goes into 18 6 times. But it's still going to cause the same amount of rotation. Like, this is 30 degrees, but it's pi over 6 radians in rotation. All right. So once we are kind of thinking about things in terms of, you know, circular functions and, arc length and things of that nature, um, since this corresponds, it still corresponds to the same, you know, 30-degree theta up here. All right. So it's still 1/2, but it also corresponds to y. And that's why at the 30-degree mark here, we can see we have a y coordinate of 1/2. All right. So these circular functions are pretty much help us determine each of the ordered pairs around the different major points in the unit circle. All right. So that's the 1/2. But something that's also kind of cool is the height of this could also be considered, 1/2. All right. And then, we could find the radius here. We could find the radius, but we know the radius is already going to be 1 because this is the unit circle. So we already know the radius is 1 here. We could totally find this length down here, which is adjacent to the 30, using the Pythagorean theorem. But we can also find that length using cosine theta. As cosine theta is equal to adjacent over the hypotenuse. All right, so we can still use our 30, 60, 90 triangle to do this, or technically we could totally use the Pythagorean theorem right here within the unit circle. So we'll go ahead and use the 30, 60, 90 triangle. Cosine of 30 being adjacent, the adjacent side is right here. So square root of 3. The hypotenuse is still 2. Now square root of 3 is like 1 point... it's just under 2 because the square root of 4 is... I'm trying to bring up my calculator on the fly here. But to the square root of 4 is 2. So the square root of 3 must be less than 2. Indeed, it's 1.73. So if you take 1.73 and you divide it in half, that's less than, 0.9. So it's still going to be shorter than the hypotenuse, which in this case, in the unit circle, the hypotenuse is 1. So that square root of 3 over 2 also corresponds to our circular function for cosine. We say cosine of s equals the x-coordinate. Well, this s is pi over 6. We already have found that this is square root of 3 over 2, and it's also the x-coordinate, and that's why you notice it here for the ordered pair that corresponds to that place on the unit circle at pi over 6 radians or 30 degrees. It also represents the distance here from the origin to the point where the right angle is created here. And this works all the way around the unit circle. So we could do the same thing at 45. You're going to have more of this 45, 45, 90 triangle happening there. And then the same thing would apply to 60 degrees. We would just reference the 60-degree vantage point there in our 30, 60, 90 triangle. But once you have built this first quadrant, you can assign all of the other quadrants based on that first quadrant. Now, you definitely need the quadrantals, but that's not too crazy. But you can direct your first quadrant values over to all of the other quadrants at will. All right, so what we'll do is we'll take a different color. Let's use black. We'll take a different color, and we will use 60 degrees as an example. If we wanted to sort of find the sort of angles that have similar coordinates from 60 degrees, we could draw a horizontal line perpendicular to the second quadrant, and that lets us know, kind of like a maybe we'll call them like sister coordinates or sister ordered pairs, if you will. If we wanted to go to the third quadrant, we would need to cross through the origin, and crossing through the origin will take us to another set of ordered pairs that are similar. And when I say they're similar, if you notice, at 60 degrees we have 1/2 comma square root of 3 over 2. In the second quadrant we have negative 1/2 comma square root of 3 over 2. In the third quadrant, we have negative 1/2, comma, negative square root of 3 over 2. And if we draw another line, we draw another line just straight down, perpendicular to the x-axis. Well, that will map to another set of coordinates that are similar. Now, obviously, in these in these quadrants, you're going to need to just be aware of the signs of your coordinates in these quadrants. So in the second quadrant, x is negative, y is still positive. In the third quadrant, they are both negative, and in the fourth quadrant, x is positive, but y is negative. So, and this works for all of them. So you can be at 30 degrees and still map, to the third quadrant by crossing directly through the origin and perpendicular to the y-axis for the second quadrant and perpendicular to the x-axis for the fourth quadrant. So this is why I say you don't need to memorize the unit circle. You can build it using the 30, 60, 90 and the 45, 45, 90 triangles, along with the circular functions that we now know, and pretty much just fill in the unit circle whenever you need it. So if you ever really want to test yourself, draw a big circle with a Cartesian plane in the middle of it, label your quadrantal angles and the ordered pairs to go with those. I would also include the signs just to kind of make for a good practice, and build your unit circle from triangles. And I promise you it'll be a lot more enjoyable and fulfilling of an experience, since all of these things will follow us throughout the duration of the course, like all the way to chapter 10. These follow us. So I hope everybody enjoyed the video. Feel free to reach out with any questions that you have, and feel free to respond to the discussion thread with your thoughts and or comments. All right, peace.